If you believed that Mercury was too hot and too close to the Sun for life to exist, we have exciting news for you. A research team has found something on the tiny planet that no one previously believed was possible. It may actually have salty glaciers, which would create an environment that could support life forms from other planets. Stay tuned until the very end to find out how life could have developed in the hidden glacier world of Mercury. With a diameter of 4,180 kilometers, Mercury is not only the smallest, densest, and oldest planet in the solar system, but it is also one of the most mysterious. Many people believe that it would be impossible for organisms to survive under such harsh conditions, but they are mistaken. Since Mercury is the planet in our solar system closest to the Sun, direct observations from Earth are nearly impossible due to the blazing light of our host star. However, the associated deadly radiation also makes any thought of a manned mission to Mercury impossible. Fortunately, there are still unmanned probes, at least in theory, but in reality, Mercury has only been visited by 2 spacecraft and examined up close. The first of these was NASA's Mariner 10 probe, which made its first flyby of the planet. This compact celestial body, which looks more like a moon than a traditional planet, still conceals many of its secrets. Planetary Pipsqueak in March 1974, followed by 2 more passes a little later. During the course of these, the earthly guest took more than 4,000 pictures of Mercury, capturing almost 50% of its surface. NASA also sent a second visitor to Mercury by the name of Messenger, the probe. Orbited the planet from 2011 to 2015 before making a crash landing on its surface that was planned but ultimately unsuccessful before this dramatic exit. However, Messenger's instruments provided a wealth of valuable new information, such as the traces of massive volcanic eruptions, mysterious depressions in the crater landscape, and indications that Mercury has a different chemical composition than Earth or the Moon. Furthermore, Messenger also provided the explanation for unusual scarps on the planet's surface, which are hundreds of kilometers long. These were actually formed because the planet has shrunk since its early days. Soon after, another exciting discovery made the astronomical headlines, although Mercury is on average only 58 million km from the Sun, and the temperatures on its day side therefore rise to 430 degrees C. There is water ice in some of its craters. Another Mercury mystery that was solved with the help of Messenger concerned the planet's surface, which appears much darker than it should. The experts found that this could be due to extensive bombardment by carbonaceous micrometeorites. After all, the dark dust from these impacts would literally color the celestial body and thus also reduce its reflectivity. However, the object to which Mercury probably owes its exceptionally large iron core was much more impressive than the micrometeorites because it could result from a collision with a larger protoplanet. A sparkling secret: does Mercury hide a diamond treasure? As we can see, a close-up examination of a planet always has the potential to provide groundbreaking new insights into the celestial body of our desire, and the good news is that the next Mercury mission is already on the starting blocks. Developed as part of a collaboration between the ESA and the Japanese Space Agency, JAXA, the Bay-Colombo spacecraft, left Earth on October 20, 2018, and has performed several swingbees of Mercury since 2021, and if all goes according to plan, it will swing into orbit around Mercury in November 2026, and once again take our knowledge of the planetary dwarf to a whole new level, and who knows, maybe Bay-Colombo will then confirm the existence of what is probably the wildest dream of every jeweler. Because it could actually be that deep inside the planet a layer of pure diamond glistens away, and just so we understand each other, we are not talking about a delicate gemstone coating here, but a sparkling region, up to 18 kilometers thick. But what was the reason for this exciting assumption in the first place? Well, researchers point to the fact that Mercury's crust and interior contain 1 to 2% carbon in the form of graphite. In this regard, the experts have used high-pressure experiments and models to investigate whether the carbon remained as graphite at the core mental boundary of the young planet, or whether the pressure was high enough to compress it into diamond. In contrast to studies in the past, however, the scientists added another ingredient to the early Mercury recipe, sulfur, which we now know also occurs in abundance on the small planet, and lo and behold, with a sulfur content of around 11%. The temperatures and high pressure at the bottom of the primordial magma ocean are enough to transform a small portion of the carbon into diamonds. But while this sparkling layer is only between 0.1 and 200 femtometer thick, it could have been significantly strengthened by the core diamonds, since these diamond crystals were lighter than the remaining molten metal. They rose to the core mantle boundary, where they deposited and formed a diamond layer that could be about 15 to 18 kilometers thick today. Unfortunately, since the gigantic gemstone deposit would then be hidden more than 600 kilometers below the surface, it would be impossible to detect it from the outside or by indirect measurements. Nevertheless, experts believe that it's conceivable that at least some diamonds were brought to the surface by circulation currents in the early days of the planet, volcanism, or large impacts. And if this is really the case, the so-called high magnesium province is considered the most promising candidate for a diamond strike. It is believed that the abnormally high magnesium level found here signifies that material from deeper depths was carried to the surface, and Bay Colombo will investigate whether diamonds were among them in the future. The finding that life exists on Mercury is revolutionary. It would certainly be spectacular to find a kilometer-thick covering of diamonds on Mercury, but let's face it, how would that compare to learning that the tiny planet is home to extraterrestrial life forms? Basically, the celestial body has been rather uninteresting for the search for possible life thus far, and that is not surprising at all. As was already mentioned, the thermometer on its day side not only reaches 430 degrees C, but it also drops to a bone-chilling 175 degrees below zero on the night side. In addition, Mercury has virtually no atmosphere, meaning that the sun's radiation reaches the planet's surface virtually unfiltered. Nevertheless, and this is the exciting part, life on Mercury may have improved because Alexis Rodriguez, the lead author of the corresponding study that was published in the Planetary Science Journal, points out that Mercury and our Earth may be much more alike than previously believed. However, what that means is that Rodriguez's team has discovered that Mercury most likely also has glaciers, but these are structures that differ significantly from their terrestrial namesakes. The key to their existence was concealed in the messenger data, which simultaneously revealed the areas with elevated concentrations of volatile elements. However, some telltale pits and pockmarked landscape formations also suggest that substances have once outgassed and sublimated there. What are still massive ice masses with clearly defined catchment areas on Earth? Mercury's salt flows, which have trapped volatile compounds like water, carbon dioxide, and nitrogen deep below the planet's surface, were exposed by asteroid impacts. According to Rodriguez, our findings support other recent studies that demonstrate that Pluto has nitrogen glaciers, demonstrating that glaciation occurs throughout our solar system, from the hottest to the coldest regions. The Mercury glaciers are formed from deeply buried volatile layers that have been exposed by asteroid impacts. Our models unequivocally demonstrate that these glaciers were most likely created by salt flow and that volatiles were present in them for over 1 billion years after they were impounded. Rodriguez also highlights how crucial these kinds of sites are to science, but what does that actually mean in practical terms? Or, to put it another way, what implications does the finding of salt glaciers have for the potential presence of life on Mercury? Rodriguez categorizes the situation on Mercury as follows. That becomes clear to us when we draw a line back to Earth at this point, because even in the most extreme regions of our home planet, such as the Chilean Atacama Desert, there are habitable zones that are only made possible by special salt compounds. This raises the question of whether Mercury has any subterranean regions that could be friendlier than its abrasive exterior. Since all other planets like Mercury may have similar mechanisms and thus open the door for possible underground life, This groundbreaking discovery of Mercury's glaciers expands our understanding of the environmental parameters that could sustain life and adds a significant dimension to our astrobiological research. Additionally, the underground button on our videos can now open the way for your new subscription. Simply hit the thumbs up and subscribe now to never miss a new video from us again. We'll see you soon.